The enthalpy of solution था कि you have a salt, it dissolves, ठीक है? That's enthalpy of solution. What are the steps that are involved? कि अच्छा, there are two steps involved. कि you break the lattice, ठीक है, gaseous ions, and then you hydrate them. You surround them with water molecules. They attract water molecules. तो ये bond formation था. This is breaking the lattice. So this was endothermic. This was exothermic. ठीक है, ये सब हमने discuss किया था. So so we did a few questions. और फिर ये डिस्कस किया था कि what happens to solubility down the group. पहले मेरे ख्याल से पूरा चैप्टर ही खत्म कर लेते हैं, फिर we'll move to questions. वो फिर हम एंड पे रख लेते हैं, क्योंकि आई गेस हमने इसके 2-3 क्वेश्चंस किए थे. क्वेश्चन हम एंड पे कर लेते हैं, चैप्टर पहले खत्म कर लेते हैं. तो एक छोटा सा पार्ट रह गया which has nothing to do with what we have studied so far. ठीक है, that is something that is new. New इस तरह के it's got nothing to do. It's a completely separate, completely different concept which you have never actually studied before. ठीक है, that thing is called entropy. ठीक है, तो this is, अच्छा ये जो चीज है ना, इसका नाम जो है this is entropy. किसी को आइडिया कि what's entropy? Umayyad, any idea? Ahmed, Saad, Tasneem, any idea what entropy is?
No.
No, sir.
ठीक है, तो लेकिन it's a very important concept. ठीक है, which जो आपने कभी भी नहीं पढ़ा. ठीक है, never studied before ever in any of your classes. ठीक है, but you might have heard the term somewhere. But it's a very, very important concept. ठीक है, it literally just means कि it means कि it's a measure of disorder of a system. ठीक है, so it's a simple definition. If something is very disordered, so that's high entropy. ठीक है, तो if something is highly disordered, तो उसको हम refer करेंगे as something having very high entropy. ठीक है, just a second. So this is something that's got very high entropy. If something is highly ordered, then that something is low entropy. This one is this is referred to as a low entropy state. And this could be applied to anything. Okay? You can apply it to your room. Okay? If your room is very dirty, untidy, that's high entropy. If it's very neat and clean, that's low entropy. Okay? So पहले तो understand करना है, make sure you know what high entropy and low entropy means. Okay? And so let me give you an example as well. One second. Entropy class. One second. Image. Not this. अच्छा, पता नहीं इमेज को क्या हो गया. तो इससे this ये वाला एग्जांपल ले लेते हैं. ठीक है, तो इसे क्या कहते हैं? रूबिक्स क्यूब, राइट? Asha, between the two, quickly tell me which one is the Which one is the low entropy state? Which one is the high entropy state? Left one कौन सा?
High entropy.
नहीं, entropy क्या था? Disorder, right? The left one में disorder क्या है? That's low disorder, right? That means it's low entropy. ML clear है?
Yes.
हाँ, तो बस ये टर्म पहले समझ लो, ठीक है? कि लो एंट्रोपी very neat and tidy, everything, ठीक है? Everything in place. And this one is high entropy, right? अच्छा, now things, कोई भी system है ना, it actually moves both ways. It moves from low entropy to high entropy state. ठीक है? That is referred to as that it is gaining disorder. So there's यहाँ पे ना there's going to be an increase in entropy, ठीक है? Entropy को ना मैं I'm going to write it as S. Entropy का जो symbol है ना, that's S. Standard entropy is with a knot on top of it, ठीक है? So when I say S, that's entropy. Delta S is the change in entropy. So if, just hold on a second. अच्छा, sorry. Achha, delta S is over here it's positive because it's an increase in entropy. This is referred to as delta का जो sign होता है, that is change in entropy, right? Or change in disorder. So if you go back, तो ये concept समझ लो, ठीक है? You got a low entropy state, you got a low disorder state, you've got a high disorder state, you got a high entropy state. Low entropy, so you're moving towards high entropy, that's an increase in entropy, ठीक है? Delta S is the change that's happening. Positive का मतलब है entropy is increasing, right? तो ये concept, ठीक है? Make sure you understand this concept perfectly. Simple concept, और make sure ये आपके brain में ना you register this concept, ठीक है? But is this clear? ये clear है? Hasina, is this clear? Emma, is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
अच्छा, and then you've got the reverse as well. ठीक है? The reverse is you go from I mean, the reverse is the reverse. It's you go from high entropy to low entropy. So this one is decrease in entropy. And this means if you're decreasing high entropy to low entropy, right? That means your change in entropy is negative now. Okay, so this is your change in entropy. So then you've got this concept, one simple concept. Which state do you think is the more stable state? Or not stable, more probable state, or the easier state? Is it the left one or the right one? Which one is easier to attain?
High entropy.
High entropy, right? मतलब Rubik's cube अगर घर पे होगा, ठीक है, you've always seen that you always end up like this, ठीक है? It's very hard to actually end up like this, right? So the point is that low entropy states are kind of like, I mean, they're very hard to attain. High entropy states, ठीक है, let me highlight this. ठीक है, the high entropy states are the ones that are more stable. These are the ones that are more stable or probable, because every time you touch a Rubik's cube, you're pretty much going to end up like this, no matter what you do. It's a very highly likely state, and this is also referred to as the low energy state. Which means you don't actually have to use a lot of energy to actually attain this state. लेकिन if you want to attain this state, you have to like make a lot of effort. Okay, so this one is the opposite. This is the unstable state. Okay, you do anything to this, you'll turn it into this. You do anything to this, you'll probably end up like this. Well, it's going to maintain its state. It's going to be stable. Okay, so yeah, idea be clear. Okay, what is high entropy state? That high entropy state is the most stable state. Is that clear?
Yes.
ठीक है बीच में कोई चीज if you don't understand anything, I mean all the concepts are like simple concepts but they're building up, right? ठीक है, so they all, you have to think of it together. So high entropy states, think about your room, ठीक है? It's easier to actually make it dirty, ठीक है, make it untidy, ठीक है, and if it becomes untidy then it maintains its state. It won't happen that one day you just wake up and your room is automatically neat and tidy. It's not going to happen. So if you want to go to a low entropy state as applied to your room, that requires a lot of effort. But the low entropy state is very unstable. Your room, if it's neat and tidy, that's a very unstable state, because even if you pretty much don't do anything, it's very hard to actually maintain that state. It would automatically go towards the untidy state, right? So this applies to everything. It applies to economics. It applies to, like, if you have a bicycle, right? Bicycle has a lot of moving parts, and those moving parts are all functioning in a very ordered way, right? So the bike, a simple cycle, that's a very low entropy state. But the cycle, that's why moving parts, when a machine has moving parts, it automatically breaks down. A car is going to break down. It's going to try to attain entropy. It's going to go towards the high entropy state. Can anyone tell me probabilistically or mathematically, why is it easier to attain this state and why is it more difficult to attain this state? Why is it easier to have an untidy room? Why is it difficult to have a neat and tidy room? Well, what is the probabilistic explanation? Why is this arrow easy? Why is delta S positive easy? Why is this difficult? ठीक है, everything breaks down. उसका वैसे मैं खुद ही बता देता हूँ कि the reason this is that your high entropy states are almost infinite. When you take a Rubik's cube, you mess around with it, there are infinite possible, not infinite, there's going to be a certain number, but it's going to be a very large number. There are almost infinite different combinations where you're going to end up with a messed up Rubik's cube, right? On the other hand, your neat and tidy and ordered Rubik's cube, there's only one state. So let's say you've got 10,000 states, 10,000 different states. 999 of them would be similar to this one. There's probably just going to be one, which is where it's low entropy, right? So it's like a coin toss. Like if you like this, this one has 99% probability, this one has 1% probability. So which is why you always end up in this state. Okay, and this could be applied to anything, like breaking down a cycle. Like if you have a cycle and it breaks down, right? There are infinite possible ways that it can break down and it can stop functioning. But if it's functioning, there's only one possible way where it's functioning. So the probability of it breaking down, that's a lot. Okay. So mathematically, is this clear that why high entropy states are the more stable states? Is this clear?
Yes.
Yes, sir.
ठीक है, तो बस एक रूल ये है कि nature wants high entropy states. ठीक है, nature always wants high. Things will break down very easily. It's very hard to put them together. It's very difficult to put them together in an ordered way. So nature really, and you can apply it to any concept, anything. Economics, like if I distribute, if I give each one of you like 1,000 rupees, then after like 10 days, that 1,000 rupees given to each one of you will be in a very disordered way. I mean, someone might spend it at a shop, TK. So the amount of money will get distributed in a very random and haphazard way. So high entropy state, everything likes to attain high entropy. TK. So what does it have to do with chemistry, and why is it important? TK. Why is delta S important? And the first thing, let me just explain to you why delta S is important. That's the importance of delta S. Again, why are we studying this? So the importance of delta S is that any system, and we're talking about thermodynamic systems, I mean, which means that systems that produce energy, right? Now they tend to produce work in two ways. One is they're going to produce heat, and that's delta H. That's your enthalpy change. Like you burn, I mean, example is burning a match, right? So it produces heat, right? And so on, lots of other concepts. Like so, every reaction, every chemical reaction, would either produce energy or it might consume energy as well. For example, what's an endothermic reaction? Like photosynthesis, right? I mean, not photosynthesis. Let's take another example. Decomposition. That's endothermic, right? So it consumes heat. But then there's another way that that a system produces energy, and that other way, not heat. Okay, the other way it produces energy is entropy change. And I'm going to explain how. Useful work gets produced when delta S is positive, which means when there's a gain of disorder, when your entropy increases, when disorder increases, and vice versa. So work gets consumed when delta S is negative, okay? As a even a partner, I'm going to explain this. That you already pretty much know, as you already pretty much know, okay, heat energy gets produced, right? So let's take the example of a car engine. Now, a lot of people think that we're talking about petrol cars here. A lot of people think that petrol burns and it produces heat. And they think that because of that heat, your car engine runs, which is not actually true. Because this heat is actually very wasteful. I mean, you don't need it actually. I mean, if petrol had burned and if it had produced zero amount of heat energy, that would have been best. I mean, you've got a radiator and that radiator removes, it's got coolants in it and it removes all the heat. So the idea basically is when petrol burns, we don't actually need this. We don't need this energy. It's completely wasteful. So how does burning petrol produces work? So the point is, when petrol burns, what happens is entropy increases. And I'm going to explain how. Okay, I've got a car engine, and this car engine has a let's say it's got a piston. Sorry. So this car engine has this piston inside it. So you got this high octane molecule. That's liquid petrol, right? So the idea is that when you burn it, it produces a lot of heat, but that heat is not needed. You just remove it, you just throw it away. So what happens when petrol burns? When petrol burns, what happens is that it combines with oxygen in the chamber and turns the octane molecule into carbon dioxide and water. So there's going to be 8 carbon dioxide molecules and 9 water molecules. So what eventually happens is that your one molecule over here, it gets converted into how many? It's 8 plus 9 kitne molecules? That's 17. So it gets converted into 17 molecules. So all of a sudden, this one molecule, after the reaction, it gets converted into 17 smaller molecules, right? So that means there's a lot of gain in disorder. Now the things in this car engine, this piston over here, the disorder has increased. Okay. So when disorder increases, the molecules are going to collide with the walls of the container and they're going to start pushing the piston upwards, right? So that's how whenever disorder increases, work gets produced. Pistons are going to start moving because of the disorder that's increasing. So the heat energy that it was producing is completely useless. You don't need that. It would have been really good if it had produced no heat at all. So this is what's happening over here, that that when you burn petrol, the entropy or the disorder increases in the car engine, which helps to move the pistons. So is this idea clear why entropy is important? Is this clear?
Yes.
ठीक है, बाकियों clear हो? Math, is this clear? Saad, Sina, is this clear?
Yes.
Yeah.
ठीक है. So this is the importance of entropy, that the world doesn't really work on enthalpy change. Like when you burn a match, you don't produce a lot of useful work. When you burn a match, you just produce some heat energy, but you don't really end up with useful work. What you can do is steam engines work in the same way, right? How does a steam engine work? Steam engine pretty much kind of works in the same way that now a steam engine is an endothermic process. So a steam engine is endothermic. अब steam engine में क्या होता है कि you've got basically you got water which is liquid, and all of a sudden when you heat it, it will turn into water which is gas. Now a steam engine is actually an endothermic process. Your nuclear power plants, all of them, they all generators, your thermal power plants, they all work in this way. So when liquid water turns into gas has a lot of disorder. There's a lot of disorder in gas. In liquid, the particles are more orderly. So when a lot of disorder gets created, the piston starts moving up. Okay, so that's the main idea. So just remember, keep this in your mind, that every system is going to produce some heat energy. It will also produce some work that is due to delta S. ठीक है, ये clear है?
Yes, sir.
Yes.
अच्छा अब केमिस्ट्री के ऊपर ठीक है we just got some hint that so how can you figure out a chemical reaction with the sign of delta S ठीक है how do we अच्छा how do we predict what that sign is positive meaning के disorder is increasing negative means that disorder is decreasing so first thing number one when you have a change of state so now when you have a change of state you got three states you got solid and you've got a liquid state and you've got gas ऐसा तीनों को draw कर लेते हैं solid is the particles will be very orderly they're all neatly packed arranged in a very regular lattice in liquids what happens is the particles are kind of neatly packed but not as close to each other or orderly they're moving and slipping past each other right so they're not and they're moving around right so they're slightly more disordered I mean they're just slipping and sliding over one another and in gases what happens is that the particles are like really far away so they're freely moving around in all directions to sum this up it's this arrow over here is delta S positive और ये वाला भी this is delta S so both of them are delta S positive so now but remember this thing that solids when you move from solid to liquid the change in disorder is not that much this one over here ये जो gas वाला ना this is very large this is a very large change because when something turns into gas then things become highly disordered ठीक है is this clear as well कि solids and liquids kind of similar disorder there's a slight increase in disorder but now there's a massive increase in disorder when you turn something into a gas ठीक है is this clear
yes,
Yes.
Yes, sir.
so that's one thing so if you and that's why you get a lot of explosions with gases TK. You don't have issues with solids and liquids most of the time when you get explosions when you get a lot of work done that is due to gas you have to turn something into gas you have to create a very large delta S positive that is how you're going to produce a lot of work ठीक है तो ये solid liquid इतने ज़्यादा work produce नहीं कर सकते ठीक है because the delta S positive is not that high अच्छा that's one thing तो अभी मैं plot कर रहा हूँ ठीक है I'm going to plot अच्छा I'm going to plot water's entropy change or water's entropy with respect to temperature so water's entropy is it's going to look like this okay do you think there's a change in disorder if you've got ice which is at -100 or ice which is at -10 is there a huge difference in disorder or is it almost the same मतलब आपके सामने ना दो ice cubes पड़े हुए हैं ठीक है one of them is at -100 degrees centigrade the other one is at -10 degrees centigrade is there a huge change in disorder or is it almost the same thing
it should be the same.
it should be the same all I mean you see a couple of ice cubes in front of you they all look kind of exactly the same even though their temperatures might be different, right? So the idea is that within a state, you don't really have a lot of change in disorder. There is some very slight change in disorder. Some molecules might be breaking away because of more kinetic energy, but otherwise, below 0 degree, इसको मैं change करता हूँ, not Kelvin 0. So there's, and let me change this. So very slight change in entropy as ice temperature changes. So as the ice temperature changes, and some particles might, some slight disorder created as particles gain kinetic energy, but very slight. So as particles gain kinetic energy. And then what happens at 0? What happens at 0 is all of a sudden it turns into liquid water. Now, when it all of a sudden turns into liquid water, now there's an increase in disorder. Now there's ice turning into liquid water, so there's a sudden increase. I said then 0 to 100. When you're dealing with liquid water, you don't see a lot of change in disorder. ठीक है, बहुत थोड़ा होगा, ठीक है, just very, very minor change. So again, like if I put a glass of water in front of you, and that one glass of water is at 15 degrees centigrade, the other one is at 50 degrees centigrade, by just looking at it, you won't notice any noticeable difference in disorder. So, but there would be some slight difference. Higher temperature for kinetic energy is more. So they might be slightly more disordered, but not that huge a difference. Is that clear as well?
Yes.
Yes, sir.
फिर 100 पे water को क्या होगा? 100 पे there's going to be a huge change in disorder, probably bigger than this. It turns into gas. So this was solid. This is liquid water. And this one over here is gas. And we are talking about water over here. I said, then, अब मुझे gas का बताओ कि when I heat a gas, do you think if you have steam at 100 degrees centigrade, you have steam at 200 degrees centigrade, and you've got steam which is at 3000 degrees centigrade, would the disorder be very similar, or would there be some difference in the disorder? This is liquid water में तो almost same था ना. Steam के अंदर क्या होगा? Is it going to be the same, or is it going to change?
It should change, maybe.
Steam के अंदर, remember, याद रखना, gaseous state के अंदर ना, the disorder changes a lot. Like if you have steam at 200 degrees centigrade and you've got steam at 3000 degrees centigrade, the steam at 3000 degrees centigrade will create a lot more disorder compared to the steam which is at 200 degrees centigrade. So यहाँ पे issue ये होता है कि इस point पे gases के अंदर, now when you keep on increasing temperature, the disorder continuously increases. Gases के अंदर disorder continuously increases, and there's a reason for that. The reason is gases expand. I mean, liquid water at 10 centigrade, liquid water at 50, liquid water at 60, they all looked exactly the same because the particles were not able to break the intermolecular forces. But the thing with gases is they expand and become more disordered. As temperature and kinetic energy increase. Is this clear? So, graph, is this graph clear to everyone?
Yes.
Yes, sir.
So just remember, gases may there's more disorder. Plus, in gases, as temperature increases, they become even more disordered. Okay? And they're able to produce even more work. So if you're running a thermal power plant, you want the gas or the steam, whatever it is, you want it to be as high a temperature as possible. Okay? And similarly, car engines would actually work better at higher temperatures because ये जो वो है ना आपके particles, they would be gases will have a lot more disorder at a higher temperature. The only thing is that the higher temperature would damage the engine as well. So which is why it's overall it's going to actually destroy your engine. So you don't want the higher temperature. But in gases, higher temperature is useful because it creates more disorder. So that's first one, change of state. Now the second, we'll just do the second law. Second one is, that was the first one. अच्छा, second क्या है? Second one. If the number of gas particles increase or decrease. Okay, that's the second one. Remember, we are only doing this so we can figure out what is the sign of entropy change. So if I have a chemical reaction, it's 2H2 gas. I've got this chemical reaction. I've got 3 gas particles. And in my products, I've got 2 gas particles. So that's a clear indication that your delta S is negative. So, I mean, because gas is decreasing. Gas had more disorder, so 3 gas particles would create a lot more disorder compared to 2 gas particles. So if the number of gas particles decrease, there's going to be less disorder. Delta S is negative. So if gas particles, ऊपर लिख देता हूं. So delta S happens to be negative. Similarly, vice versa, if the number of gas particles, they increase. Like I have 2 NH3 gas particles. And it gets converted into N2 gas. So this one is delta S positive. This one over here is delta S positive. So if your gas particles are increasing, you've got more gas particles. So that means disorder is increasing. Ye be clear? Is this part clear?
Yes, sir.
Yes, sir.
So bus so we'll leave this at this point. Complete kar lete hain isko. The third one is that Let's move to the third one. How to predict the sign of delta S. So the third one is that if your if everything is in the same state, so if number of particles increase or decrease, so if your number of particles increase, that just means that delta S is positive. There's more disorder. If it decreases, that means delta S is negative. An example for this one is the example होगा. Let's say I've got one second. So let's say I've got this reaction. See, the reaction was so complicated, let me just write it down. And this will be 3 particles. Then they react. And you get so all of them are in aqueous state, right? You're going to study this a lot later on, this reaction, but you got how many particles? You got 4 particles. And over here you've got 7 particles in total. 6 ye or 1 ye. So your disorder is increasing. It's you got more particles, so that means it's going to be more disorder. Okay? Is this clear as well?
Yes, sir.
बस ठीक है. यहाँ से ना फिर हमने 3 points अभी किए chemical reactions. We'll continue with this later and we'll finish this. It's a very small topic. ठीक है? I mean this one part of energetics, but really small. ठीक है? तो फिर कल continue करते हैं. ठीक है?
Okay, sir.
Let's continue tomorrow then. Okay then. Take care.
Love, sir. Thank you.
Allah Hafiz.